objective of this experiment to use linear air track to investigate Newton's second law of motion.
These are the apparatus that we use in this experiment, which are air track rail, blower, pressure tube, gliders, flag, photo gates, masses, mesh hanger, string, and pulley.
For procedure, first assemble the linear air track as shown in the figure. Second, switch on the air pump and let the air blow through the track for several minutes. Balance the track by adjusting the screws on the legs of the track so that the glider stays stationary and does not glide to either end when let go. Third, insert one hook at one end and a flag on top of the glider as shown in the pictures above. Fourth, measure and record the mass of the hanger and length of the flag. Fifth, attach one of the end of the string to the hanger and the other end to the glider. For the sixth one, place mass with a mass of 20 grams on the hanger and put the string over the pulley. For the second last procedure, position the glider exactly before the photo gate. Release the glider and record the time shown on the photo gate. For extra note, in order to avoid mass from crashing and scattering to the floor, catch the glider with your hand before the hanger reaches the floor. Lastly, repeat 2 more times to obtain the time average values and repeat the procedure 4 more times with 20 each added to the hangers as shown below.
So, this is the result that we obtained from the experiment. For the total of slotted masses on hanger, we added 0.02 kg of masses for each experiment. For the time taken, we will take the average for getting the accurate result. To get the average of the time taken, we need to get 2 readings of time taken for each attempt and divided it by 2. For the total mass of hanger and slotted masses, we need to add mass of hanger M1 and total of slotted masses on hanger M2. For weight of hanger and slotted masses, we need to multiply the total mass of hanger and slotted masses with gravitational acceleration, which is 9.81 meter per second. And lastly, for the acceleration, we need to multiply 2 with the length of leg and divide it with the square of the time taken. As for analysis 1, we need to plot a graph of weight force Fn versus acceleration ams to the power of -2. So here's the graph. 2. What does the result tell us? The result tells us the higher the force exerted on the object, then the higher the acceleration will be. This also shows that the force has a relation with acceleration, which is the force is directly proportional to acceleration and also inversely proportional to mass. Number 3, do these results support the Newton's second law? Yes, these results support the Newton's second law, which is F equals to ma. As for the discussion, based on the data collected, the weight force of hanger and slotted masses will increase due to the increasing of the acceleration. This proves that the weight force is directly proportional to the acceleration. From the plotted graph, it's shown that the relationship between the force and the acceleration is related to the Newton's second law of motion. Newton's second law of motion is a quantitative description of the changes that a force can produce on the motion of a body. Therefore, when the weight force of hanger and slotted masses is increasing, the acceleration also increases. Based on the data that were obtained, the graph were plotted according to the data. The graph shows the weight force Fn versus the acceleration ams to the power of -2 according to the Newton's second law. The acceleration of an object is dependent upon 2 variables, which is the net force acting upon the object and the mass of the object. By moving the object such as the glider, would produce acceleration and change the speed of motion, F equals to ma. The possibility of error in this experiment could affect the acceleration, such as if the rail is not stable, then the accuracy of data could not be obtained. Thus, the rail should be placed on a flat surface. For the conclusion, the objective was successfully achieved. From this experiment, students know that the net force upon an object is the same as object's mass times its acceleration. Additionally, it is a rule in figuring out how the net force on an object and its acceleration is related with each other. The Newton's second law of motion was also proved by this experiment. Hence, the weight force of hanger and strutted masses is increased. The acceleration also increased.
For experiment 4, the objective is to determine the coefficient of static friction of different surfaces.
Introduction of frictional force. Friction force is when two bodies are kept in contact. Electromagnetic forces act between the charged particles at the surfaces of the bodies. As a result, each body exerts a contact force on the other. The magnitudes of contact forces acting on the two bodies are equal, but their directions are opposite, and hence the contact forces obey the Newton's third law. There are two types of friction, which are static friction and kinetic friction. Static friction is the friction that acts on an object that is at rest. Static friction is the force that must be overcome in order to move a static object. The maximum value of static friction force is given by Fs max equal to mu s n, where mu is the coefficient of static friction and n is the normal force. The coefficient of static friction is dimensionless, constant that depends on the object and the surface it is laying upon. Kinetic friction is the friction that acts on a moving object, and the kinetic frictional force is given by Fk equal to mu k n, where mu k is the coefficient of kinetic friction and n is the normal force. In this experiment, the frictional force between a wooden block and the rubber surface on a horizontal and inclined plane will be measured, and from the plotted data, the coefficient of static friction will be obtained.
So for the apparatus that we need to use is wooden block that have rubber covered at one side, 50 grams of masses, 10 newtons spring scale, string and tabletop. And this is the setup for the apparatus.
As for the procedure, first, the mass of wooden block was measured and recorded as m. Second, the apparatus was set up as shown in figure 5.2. Third, the tabletop should be made sure to be stable and horizontal to the ground. Fourth, the spring scale and the wooden block should be attached with a string and placed horizontally on the tabletop, making sure the rubber side of the block is faced downward. Fifth, a 50-gram mass was placed on the wooden block. Sixth, the spring should be pulled slowly. Once the block starts to move, the reading of the spring scale should be recorded and the value Fs should be tabulated in table 5.1. 7th, step 4 until 5 should be repeated for 3 trials. 8th, step 5 to 6 should be repeated until a total of 500 gram mass is added to the wooden block. And the last one, 9th step, is step 1 should be repeated until 8. This time, ensuring the rubber side of the block is facing upward. The data should be tabulated in table 5.2.
These are the results of table 5.1 for rubber surface towards the floor. And these are the results of table 5.2 for non-rubber surface towards the floor.
For analysis, question asks to draw and label the free body diagram of the wooden block. So this is how the free body diagram works. Normal force acting upward on the wooden block while weight acting downward. Wooden block is pulled with force. For the second one, plot graph of static friction force against normal force for the rubber surface and non-rubber surface. The picture shown is the graph for rubber surface towards the floor. And this is the graph for non-rubber surface towards the floor. Question 3. Use the gradients obtained from the graph to calculate the coefficient static friction for each surfaces. 5.1 shows the calculation for rubber surface towards the floor and 5.2 for non-rubber surface towards the floor. The answer for 5.1 is 0.8. And for the 5.2, the answer is 0.23. Analysis 4. Compare and discuss the coefficient of static frictions obtained. get the comparison, we use 0.8 and minus it with 0.23. The answer will be 0.57. Coefficient of static friction for rubber surface towards the floor is greater than non-rubber surface towards the floor by 0.57 differences. This occurs because rubber produces more frictional force than non-rubber does. Let's jump on to questions. Question 1. How can anti-lock brake stop a car in a shorter distance than regular brakes? Anti-lock brake system, or ABS, assists by restoring traction to tires when facing emergency states. This will affect car's force because tires' friction is less than its sliding friction. Anti-lock brakes are able to provide shorter controlling stopping distance because zero pressure is restored quickly and tires will glide smoothly avoiding subject without gripping to the road, while regular brakes are unstoppable at a shorter distance when interfering with object and tires become frictionless, causing tires to glide and hit the object. The answer is material rubber used to interact with the floor has the highest coefficient of static friction. This statement matches with hypothesis created because rubber is a very sticky substance and contains long chains of link to each other and strengthen them. Respondent object of friction to floor determines the coefficient of static friction. First questions. Once the mass begins to slide, does it move smoothly or does it undergo stop and go motion? Explain the motion. The answer will be, the mass will begin by undergoing through stop and go motion. That motion undergoes stop because of traction applied on the floor and it has friction. This will grip the wooden block from moving freely and cause slow paced movement till it stops naturally.
Now we move to discussion. The experiment was done to determine the coefficient of static friction of different surfaces. The coefficient of static friction could be determined from the plotted data of the graph, which are graph of static friction force against normal force for the rubber surface and non-rubber surface. The gradients obtained from the graph was used to calculate the coefficient of static friction for each surfaces using the formula of gradient. M equal to y2 minus y1 over x2 minus x1. From the graph of the rubber surface, the coefficient of static friction is equal to 0.80, while for the graph of non-rubber surface, the coefficient of static friction is equal to 0.23. The difference between the coefficient of static friction of two surfaces is equal to 0.57. While the experiment was conducted, there were some improvements that could be made. The observer should place their eyes perpendicular to the spring scale while pulling it. This is to avoid the error in reading that could affect the data. Next, take a set of reading by different observers during the observation in order to minimize the parallax error due to mistakes in reading scales.
As for the conclusion, the differences between coefficient static friction occur because of surface roughness. Rubber surface have the highest coefficient of static friction because the rubber makes the surface of the mass more rough.